Right now, we'll do some practice question on how to draw a force diagram. Okay, so let's look at this particular question. Take a moment to pause the video. Okay, so right now is essentially is to draw a force diagram to try to find what is the value of F. The concept applied is object in equilibrium means that net force equals 0 because this is held in equilibrium. Okay, highlight this. So net force equals 0. And net force equals 0 simply implies that when all the forces arrow add up together, they will end up at the starting location. So you add up weight, you add up tension, you add up W, you'll find that they will all end up at the same location. Okay, meaning that you end up over here. So draw by scale diagram. So the first thing is to determine the scale. So let's say 1 centimeter is to 100 Newton. So the first thing we can draw, of course, is W. Okay, that's the easiest way because we know that it's straight down at 1000 Newton. So just draw a 10 centimeter line. And then the next line that we can draw, we cannot draw F because we do not know the direction and the magnitude, but we do know tension. So we do know the tension is 45 degrees, okay, because it's indicated. So this is 45 degrees, and we do know the value, which is 1002. So this is another 12 centimeter. So this will be the tension. And since we are applying this when all the forces arrow add up, they end up at the same location. So which means that F would have to be starting from here and end up over here. So this will be your F. And we obtain F by just measuring the length and angle of F. So the angle that we are obtaining is try to measure this. So the answer should give you 8.6 if you draw it accurately, which is 860 Newton, and it's roughly about 10 degrees from the horizontal. It's a very similar question. So in this case, they help you by explaining why the resultant force of the three forces must be 0. Again, the highlight or the key to solving is that it comes to a rest. Okay, velocity comes to a rest. So the explanation is girls come to rest and stay at rest means that the acceleration of the girl is 0, and thus by Newton's first law of motion, the resultant force of these three forces must be 0. The next question is determined by scale diagram the forces of T1 and T2. So again, the net concept is that if the forces add up, they all will end up at the same location. So it's quite similar to the previous question. This time around we use a scale of 1 centimeter to 500 Newton. So this is roughly about 2.5. So again, the weight is always acting down. So let's try to draw T1. Okay, you find that T1 we have a bit of problem. T1 we know the angle, we know the angle which is roughly about 10 degrees indicated over here, but actually do not know what is the length of this T1. Okay, and we are supposed to find that. So in this case, you just draw a line and extend it and just leave it as that. Okay, because we are going to draw T2 on top the same way. Again, T2 we do not know the length, but we do know the angle, which is in this case 30 degrees. Okay, how do we obtain 30 degrees? Is that you draw a horizontal line, and this by alternate angle, this one will be also 30 degrees. So this will be 30 degrees, and you just draw one line. And remember, when forces all arrow add up, they will all end up in location, which means that the only possible case is that to complete this triangle is that the T1 must be only this length from here to here, and T2 must be this length from here to here. So this must be T2 and this must be T1. So what you simply need to do is to just measure the length of T1 and T2 in terms of centimeter and convert them into Newton. In this case, T1 and T2 angle is already known. Okay, because you don't really have to indicate. Okay, because this is of course 10 degrees and this is of course 30 degrees. Okay, so that's how you do and apply questions. Please subscribe and support my channel. For my other physics video lesson arranged according to topics, please visit my blog at boringphysics.wordpress.com. You can subscribe to my channel to be informed when I upload new physics video lessons. Thank you.